Okay, thanks, Matt. I'll go ahead and get started by introducing myself. I'm Rob Walker, the Chief Technology Officer of NSWC Crane. I've been in this role for several years now, and I'm really excited at the opportunity to present to all of you. If you go to the next slide, please. The NSWC Crane is just one part of this overall naval entity called the NRNDE, the Naval Research and Development Establishment. And so one of the things I wanted to point out initially is that some of the things that you're going to hear about this week from the various sessions are just the crane piece of this overall naval picture. But we partner closely with all these other labs that you see around the perimeter of the screen. Notice we're a little unique in that we're in the central part of the U.S. as compared to the others that are mostly on the coastline. So we do definitely want to emphasize that regional outreach and getting to the local partners, but we do a lot of business outside the region, internationally even. So I just wanted to help give you that perspective. And if you hear some things that I talk about that don't fall into the Crane portfolio, they probably align with one of the others. We have connections into those other labs. We can help make connections there. Always happy to do that. So feel free to reach out if you ever have a need to get into some of these other organizations. Next slide, please. And so the Chief Technology Office tends to focus on what we call the Navy after next. And so to put that in perspective, we have the current Navy, which is the Navy that's out there today operating with the ships, submarines, aircraft, etc., the things that they take with them when they go on missions today. Then we have the next Navy, which is really what we consider the programs of record, the things that are already in the budget, the acquisition programs that are underway, the things that are coming down the line. We support the current Navy with our sustainment portfolio, keeping those systems functioning, up to date, modern, etc. We support the next Navy by supporting the program offices, the acquisition programs, the programs of record, but we also support the Navy after next, which is being prepared to fight future battles to make sure our Navy is, like we like to say, our Navy is never in a fair fight, that we always have a competitive advantage against any potential adversaries. And so the Department of Defense, the Department of Navy has spent a lot of time and spends a lot of investment trying to figure out what those critical areas are. And the DoD in particular has identified a number of modernization areas where they fear that we don't have a competitive advantage or not enough of a competitive advantage. And so I've just shown a website here, CTO.mil. You can find it online. You can see those DoD modernization priorities. So what I thought I would do initially is just go through those modernization priorities and talk a little bit about Crane's interest in some of those. So if you go to the next slide, please. AI, ML, artificial intelligence, machine learning, that's a big one. That's one of those broad spectrum things that just has the potential to affect everything we do, whether it's from logistics to operations, autonomy, business systems, just any number of applications. The DoD has expressed a lot of concern that there's tremendous amount of investment going on in industry. And there's also a lot of investment going on with potential adversaries. And so they want to make sure that there's plenty of investment and expertise being developed within the United States Department of Defense. We have a lot of interest in that at Crane as well. We several years ago formed something that we call CRADLE, which stands for the Crane Artificial Intelligence Development Lab. So we've made some strategic internal investments. We've purchased some hardware, software, invested in some workforce development, trying to get our professionals up to speed. And we see that as a continuing area of emphasis. At the DoD level, They formed something called the JAIC, the Joint Artificial Intelligence Center, that's really leading the way across all of DoD. We're one small piece of that, but certainly an area of interest across all the departments at Crane. We move on to the next slide. Biotechnology. This isn't really a sweet spot for Crane. We aren't really involved there. If you have interest, that tends to fall with some of those other labs that I showed, so I'm not going to spend any time on this one. Next slide. Autonomy. This is one that's of growing interest. You see the unmanned aircraft shown there. There's also unmanned ground vehicles and particularly unmanned surface and undersea vehicles. From the Navy perspective, you know, an undersea vehicle, once you send it on a mission, it's very difficult to communicate with it. And so autonomy is to be expected. And meanwhile, there's a lot of interest in doing the same kinds of things with unmanned surface vehicles so that you can send them on missions that go beyond your range of normal communications. So we are seeing a lot of interest from customers across the Navy portfolio of air, sea, undersea, and on land. And so we do expect to see involvement across multiple Crane departments in autonomy. Next slide. And then cyber, that's another one that really spans really all of the Department of Defense, all of Navy, all of Crane. Our particular interests are ensuring, you know, that the systems that we deliver to the warfighters are safe. And one aspect of that where we've had particular focus is on the components that go inside those systems. Crane is nationally known for our support to some of the trusted electronic systems. And so you're looking at things like solid state drives or FPGAs, or, you know, circuit boards, components, and things like that. Whereas a lot of others might be more in tune to the networks, the operating systems, the software. We've got a lot more focus on the hardware of these systems. We still do have a lot of interest in the rest of the network, but a real specialty area for us tends to be more on the components and the microelectronics. Next slide. Directed energy. This is another one. It's gotten a lot of attention in the Navy for many years, but it's not a focus area of Crane. It actually tends to fall with some of our partners. We do support some of these systems, but it's not a key focus area for Crane, so I'm not going to spend any time on this one. Happy to answer questions later and direct you to others, but go ahead and skip to the next slide. Yeah, this one, 3 on one screen. So the fully networked command, control, and communications, or FNC3. For us, most of that fully networked see-through takes place within our expeditionary department. You heard from them earlier today. Expeditionary, in terms of the Navy, means people who have left the ship, they've gone on an expedition. And so we're talking about the ship to shore connectivity. We're talking about once you get ashore and you build networks. Our adversaries or potential adversaries are developing weapons that are designed to keep us away from their shores. They want to have control of the area around their nation, understandably so, but we want to be able to get there to be effective when we need to. And so we need to be able to figure out how to project forces ashore from a distance, and to do that, we need command and control. We also need to be thinking about these unmanned surface vehicles that I mentioned before, or even unmanned aerial vehicles, unmanned undersea vehicles, you know, when they surface to exchange information. Robust networks, reliable networks, plenty of bandwidth. What to do if the satellite networks become contested and are unachievable. Really anything we can do to ensure communications remains a critical capability. Microelectronics, I already talked a little bit about this on the cybersecurity side, but even beyond cybersecurity aspects, just the trust in microelectronics in general. Even now, primarily driven by COVID, we've seen how vulnerable our supply systems are, and there's a shortage of microelectronics. And I hear that it's hard to find new automobiles now because the automobile manufacturers can't find microelectronics to put in the cars and trucks, things that we want to buy. And so the Department of Defense has recognized this is a critical area of investment. We don't have a lot of domestic infrastructure for microelectronics. We are vulnerable. We need to do something about that. So there's been a lot of investment in microelectronics. It's been an area of expertise at Crane for a long time because we want to make sure that the systems our warfighters are using can be trusted. Are they counterfeit? Can we figure that out? A lot of times somebody might try to substitute a part and sell it on the market as if it's new or if it's a different specification than what it is. How do we find that out? How do we make sure that the systems we give them are safe? How do we make sure, on the cyber side, that they're not corrupt, they're not vulnerable to some kind of a cyber attack? Anything we can do to ensure a trusted supply chain of reliable microelectronics will be absolutely critical. And then on the quantum science, it's a small but growing area of emphasis within Crane. We've used some of our internal investment money to fund some research into a variety of quantum technologies and plan to continue doing so. We've developed some partnerships with academia and industry already and are actively seeking more. Happy to go into some more detail with that if people are interested, as with all these other subjects, but just say that this is certainly a growing area of interest at Crane. Next slide. Hypersonics is a big, fast growing area. This is one that has gotten, again, a lot of attention in the media. It's one where the Department of Defense came out and just stated flat out, our adversaries are getting ahead of us in this field. We need to catch up and pass them, and we need to lead in this area. So each of the services was given a role and said, you will quickly develop hypersonics weapon systems, and so we've been actively involved with that. You might have heard some of that already from some of the other presenters in the APBI, but we are certainly interested in doing what we can to help the Navy and the other services, for that matter, develop and test and field these hypersonic systems. Next slide. Space. We don't do a lot with space systems. Some of our other Navy partners do much more than we do. We have some involvement with some of the components on board space systems. Some of the things like electronics, how do they operate in a radiation heavy environment? So we have a group that's actively involved in radiation hardened electronics systems. Battery systems is another area where we provide some support to space. So we do have some niche pieces where we get involved in space components, but it's not a huge area of emphasis for Crane. Next slide. And then 5G, another growing area of interest. As 5G systems come on board and become available, we want to make sure that we take advantage of those for our warfighters. It goes back to some of the fully networked C-cubed discussion that I had earlier. But another component of it that's of interest to us is what happens when our potential adversaries start using these 5G systems. The Spectrum Department, you'll hear from them tomorrow. Their big focus is electronic warfare, and you'll hear them say things like control the spectrum, control the fight. So we want to be able to control the radio frequency spectrum And these 5G systems can make that a difficult thing to do, even more difficult than it is already. So we need to understand how to use 5G systems for ourselves, but we also need to understand how others are going to use them, and we need to be prepared to see where the vulnerabilities of those systems are, see what we might be able to do to sustain a communications advantage so that that we have the ability to communicate and our adversaries don't, because that will give us a significant edge in any conflict.